Hey guys, welcome to Unit 7, Lesson 4. Our topic today is Unit Circle. Uh, I want to get started with the do now. It says in trigonometry, a unit circle is a circle with a radius of 1 and is centered at the origin. So, very important for us to know. Oh, sorry about that. What is a unit circle? It is a circle with the radius 1. First of all, know what a radius is. If you have a circle, and that's your center. The distance from the center to the circumference is called the radius, right? And it is centered at the origin means what? It is centered at the point 0, 0. So if I was to draw my picture, basically, how do you start? Anytime you sketch a circle, you always start with the center, which is 0, 0. And then your radius is what? 1 unit. So I'm going to go one around to the left, right, top, bottom, and then I'm going to just connect it. Right? It's not a perfect circle, but that's it. So that is a unit circle. If I was to talk about these points, what is this point? This point is what? 1. Since it's on the axis, my y coordinate is going to be 0. This point would be what? It's on the y-axis, so my x is going to be 0 and y is 1. This is negative 1, 0, and this point would be 0, negative 1, right? So I know it's not asking me to, oops, I want the eraser. It's not asking me to write the equation of a circle, but let's quickly review the equation of a circle. Equation of a circle is of this form. The standard form of an equation of a circle is x minus h square plus y minus k square equals r square. So what are h and k? H and K are your center points. So you need two things to sketch a circle. We did that earlier in the year. And R is your radius. Radius, again, I talked about what a radius is. Distance from the center to the circumference. So that's your center. So my center here is what? 0, 0. And my radius is what? 1. So let's substitute in here. X minus 0 square plus y minus 0 square equals 1 square. And if I simplify this, x minus 0 is x, and x squared would be just x squared. Same thing, y minus 0 is y, and it'll be y squared equals 1 squared is just 1. So that is the equation of a unit circle. I don't know if you can relate this to your Pythagorean theorem. It does look like, a squared plus b squared equals c squared, right? So anyways, we'll talk more about that in the future, but let's get started with the lesson. It's saying sine and cosine on the unit circle. So in trig, we're going to be mostly talking about focusing on the two functions, sine and cosine. We will be talking about tangent a little here and there, but mostly our graphs and everything will be talking more about sine and cosine. So it's saying let's create a triangle. In the first quadrant, again, let's label our quadrants. It goes in counterclockwise direction, 1, 2, 3, 4. And it's asking us to draw drawing a 45-degree angle, then by dropping an altitude to the x-axis. So this is what's asking. Always remember, my initial ray is always glued to the x-axis and my terminal ray. So if that looks like a 45-degree angle, and I'm going to drop an altitude, right, and that's 90 degrees. And it says label the reference angle. That's your reference angle, theta, right? And would you agree that this height is, this is going to be just y, right? Some y distance we traveled because it's the vertical. And similarly, this is going to be, this is x, right? So this is your x. And I know this whole distance, it's your radius, right? Radius of the circle, which is what? 1. So would you agree that this is also going to be 1 because it's also the radius? All radii in a circle are congruent. So let's do find sine of theta. How do I find that? Remember from SOHCAHTOA, you have seen that before. I like to write it as a ratio. That way we don't mess it up. What does this mean? S stands for sine, C for cosine, T for tangent, O is opposite, H is hypotenuse, A is adjacent, and h is hypotenuse again. So that's what it is. So basically, if I'm saying sine theta, that's your sine theta. So sine theta is what? That's O over h means opposite over hypotenuse. If you're a little confused, I'm going to quickly sketch a triangle so that we know. Given a right triangle, if this angle is theta, across from theta is my opposite side, and next to is adjacent, and hypotenuse is always across from 90. So this is what I'm talking about. I'm talking about sides. Whenever I talk about opposite, adjacent, and hypotenuse in trig, I'm talking about the sides of a triangle. So here, sine theta is opposite over hypotenuse. So what is opposite to this theta? It is my y over hypotenuse is 1. So basically, anything over 1 is just y. So can I say sine theta is y? Similarly, what is cosine theta? Now, cosine is my second function, which is a over h. A is your adjacent and h is your hypotenuse. So that's my angle, theta. So adjacent is x and hypotenuse is 1. So it's x over 1, which is same thing as x. What can we conclude from here? Therefore, the point xy on the unit circle is cosine theta sine theta. Remember, cosine is your x, sine is your y. We need to know that very well, very, very well. I also want to talk about tangent theta. Let's write that down here. Tangent theta. Tangent is what? What's the ratio for tangent? Opposite over adjacent. So what's opposite? Y over x, right? So what was my y? My y is sine, right? And if I want to write it in terms of trig function, y is sine, x is cosine. So can I also say tangent theta is sine theta over cosine theta? And that's a very important fact we will be using quite often. Okay, so, oops, can't slide up. Let's secure. Yes. So we can use the unit circle to determine the exact sine, cosine, and tangent value of quadrantal angles. I wrote up above what are your quadrantal angles. Any angle divisible by 90. So we know sine theta is y, cosine theta is x. Again, alphabetically, x comes first, y comes second. Similarly, c comes first and s comes second. So there's no chance of getting it wrong. Tangent is, theta is change in y. It's basically your slope, change in y over change in x. That's where it comes from. So you can say sine theta over cosine theta. So let's get started with example 1. Find the exact value. Okay, this is very, very important. When you say exact value, cannot give decimal answers. I need them as fractions, as radicals, whatever they are. If you give a decimal answer, that will not be accepted and you will not get any credit. Okay, so please be very, very mindful that exact value means no decimals. Find the exact value of each of the following quadrantal angle. Again, we know what our quadrantal angles are. I'm going to write them again here: 0, 90, 180, 270, and 360 by drawing a unit circle. Okay, so let's draw a unit circle. So our unit circle, we should be very comfortable by end of this lesson to sketch a unit circle. A unit circle is a circle with radius 1. I could have drawn better, but I guess I'll suffice with this. So I know this point is what? 1, 0. This is, since the radius, again, the radius is 1. It's on the axis. I went x to 1 unit to the right, but there's no movement. There's no vertical distance. I travel, so, and this is 0, 1. This is negative 1, 0, and 0, negative 1. Right? So what do we need to do? How do we find these values? Remember, 3 things that are written up here. I'm going to write again. Your cosine theta, or whatever angle we're looking for, that's your theta, okay, is your x. Your sine theta, since it's a unit circle, is your y. And your tangent theta would be your sine theta over cosine theta, or I can say it's what? Y over x. Whatever seems better for you. Okay, So sine of 90 means what's my theta? 90. So I'm going to take a different color. Sine is what? Your y value. So it would be just 1. Tangent of 270. Tangent functions will require you to do a little bit more work. It is what? Y over x. So what at 270, which is here, I'm going to write the angles also so it's easier for you to see. This is 0 degrees, 90, 180, 270, and 360. And I'm going to put the negative ones also. Negative 360, it's negative 270, negative 180, and negative 90. So depending on where you are. Right, so tangent of 270. Tangent is what? Y over x or sine over cosine. So sine of 270, I'm going to show you all the work. Eventually you can choose to skip the work. And over cosine of 270, right? So what is sine of 270? Sine of 270 is negative 1. Cosine of 270 is 0. Which is what? You have 0 in the denominator, so it is undefined. So let me tell you one thing. Wherever your cosine is 0, tangent is going to be undefined. So I'm going to write here. For all angles, when cosine is equal to 0, cosine theta is equal to 0, tangent theta is undefined. So tangent of 90 is also going to be undefined and so on. Okay, so sine of 180, and use different colors. Sine is what? Your y. So what is the y coordinate at 180? 0. Tangent of negative 180. So I'm going to go negative 180. So again, tangent is sine over cosine. Sine is 0. Cosine is negative 1. 0 divided by negative 1 is just 0. Okay, we don't get confused with the 0 in the numerator. I don't really care about zeros in the numerator. It's going to be 0. But if you have a 0 in the denominator, it is undefined. Cosine 360. Cosine 360. Cosine is your x, which is 1. Sine of negative 270. Negative 270 is here. Sine is your y, which is 1. I'm literally looking at the x or y coordinate depending on which function. Cosine 270. Again, cosine is your x. At 270, your x coordinate is 0. You don't have to do this over and over again. Eventually, you should be able to kind of know that. Tangent of 90 would be what? Now look at this. At 90, my cosine is 0, right? My cosine or my x coordinate is 0, so it's going to be you don't even have to show the work. It is undefined. But you should understand why it's undefined. Cosine of negative 90. Negative means you're going in the clockwise direction. So cosine is what? Your x. So it is going to be 0. So this is how you find the values of the quadrantal angle. Okay, so now what are we going to talk about more? 4 quadrants in the unit circle. 4 quadrants and the unit circle. So the placement of a right triangle can be in any 4 quadrants of the unit circle. The triangle that we drew on the first page, it can be in any unit circle. Remember when I was talking about the reference angles, we said a reference angle looks like a butterfly. So do you see 4 triangles? So you can sketch those triangles in any of your 4 quadrants. The location of the triangle must take on an appropriate positive and negative signs of the quadrant. Since sine is y, sine will be positive where y is positive, and since cosine is x, cosine will be positive where x is positive. So think about it. Isn't everything positive in the first quadrant, x and y? I'm going to talk in terms of x and y, and then we'll translate in terms of sine and cosine. In the second quadrant, my x is negative means what? X is negative, y is positive. Third quadrant, x and y both are negative. Fourth quadrant, x is positive, y is negative. Now, I don't want to know this. I want to talk in terms of sine and cosine. So we're not doing something very different. We're just replacing x with cosine and y with sine. So here, can I say that my sine will be positive and my cosine will be negative? My x is negative, so sine and cosine are both negative. If sine and cosine are both negative, think about it. Won't tangent be positive? oops, so tangent will be positive. And the last one is what? My cosine is going to be positive because my x is positive and my sine is negative. So I'm going to actually clean this up and introduce to you an acronym, because remembering all this can be a little crazy, right? So all students take calculus. So ASTC. We all are very good with abbreviations. So ASTC means what? ASTC. So when I write ASTC in my fourth quadrants, it means all my trig functions are positive here. Only sine and its reciprocal, we'll get into reciprocal functions eventually, are positive. Only tangent and its reciprocal is positive, and only cosine is positive. If you are having difficulties, remember it, write that T. So that's what it means. So you don't have to every time do, oh, is x positive, is y positive? No. Remember your ASTC. So anytime you draw the coordinate plane, you're going to be writing ASTC, and that will help you understand which trig function is positive or negative in a given quadrant. So let's do a few examples related to that. Example 2, it says if the sine theta is positive and the cosine theta is negative, in which quadrant does the terminal side of angle theta lie? Okay, so whenever you're asked to given more than one criteria, so we're given two criteria here. We're talking about sine and cosine functions, and we want to find out what quadrant we will be in. So you're going to take one thing at a time. Always draw your coordinate plane, write your ASTC, and even if you're good with your quadrants for initial times, I would say write them out so that you know which quadrant we're talking about. And take one thing at a time. So sine theta is positive. Remember, sine is positive and everything is positive in the first quadrant. So I'm going to put a check for that. Sine is positive in the second quadrant, right? So now the second one is my cosine function, and cosine is negative. Cosine is negative in the second quadrant and the third quadrant. So both of these meet the criteria in what? The second quadrant. So your terminal side is in the second quadrant. What does that mean? Basically, you don't have to sketch that, but I just want to show you what this means. That your initial ray is always glued to your x-axis. So your angle would be anywhere in the second. It could be this, it could be here, it could be here, anywhere in the second quadrant. It's somewhere in the second quadrant. That's what it means. So I just wanted to bring that up. Okay, example 3. It says secant theta is less than 0 and tangent theta is also less than 0. Then the terminal side of angle theta lies in which quadrant? First of all, what does less than 0 means? So if you had a number line, going back to our number line, and 0 is like right in the middle, let's say. So all the numbers that are less than 0 are what? Negative numbers. So I'm going to write less than 0. And anything greater than 0 are what? My positive numbers. So your negative numbers are less than 0 and positives are greater than 0. So another way of saying that this is negative, we can say that secant theta is less than 0. Tangent theta is also negative. So now what do you do? Again, the same thing as we did for the last example. Sketch your axis, right? And you don't have to do the angles because it's not really talking much about the angles. All we need to do is write ASTC. Then based off that, we will determine what quadrant the terminal side of the angle lies. So secant theta is negative or less than. Secant is negative, and remember secant is the reciprocal of cosine. So we just did that. Cosine is negative in the second and third quadrant. And tangent is negative in the second and the fourth quadrant. So what quadrant is the terminal side of the angle? It is in the second quadrant because I got two checks, right? Both of them met the criteria for that quadrant. Example 4. A circle centered at the origin has radius of 10 units. The terminal side of an angle theta intercepts the circle in quadrant 2 at point C. The y-coordinate of point C is 8. Find the value of all 6 trigonometric functions. So we want to find this. So let's write that down first and then we'll draw a picture. I want to find all my 6 trig functions. I know my 3 basic ones are sine, cosine, and tangent. And once you find the ratios for these, you can always flip them and write the ratios for the other remaining 3. So how do we determine that, I always like to write the opposite of it. So the reciprocal of sine theta is what? Cosecant theta. Reciprocal of cosecant is secant theta, and reciprocal of tangent is cotangent. So if I write across, I know all I need to do is switch their fraction. So now, how do I interpret all this information given to me? How do I come up with my ratios? So what you do is sketch out your coordinate plane, and it says a circle centered at the origin has a radius of 10 units. So if I had a circle, I'm going to do a dotted circle. Let's say this is my circle with a radius of 10 units, right? So would you agree that this is my radius, right? So this would also be, and we're in the second quadrant. It said second quadrant, so I'm going to just work in the second. So this is the radius, so this is what? 10 units. Now you want to do what? You want to drop a perpendicular. Remember, we're going to try to do a reference triangle. So we're dropping a perpendicular to the x-axis, always to the x-axis. Going back to our lesson 1, we always talked about it. Your reference triangles will look like a wing of a butterfly, right? They always are the closest way. Your reference angle is the closest way to get to the x-axis, not the y. So please be very careful of that. Your angle is between your terminal ray and the x-axis. So that's your angle. And it also says the y-coordinate of point C. This is your point C because that's where this radius or the terminal ray is intersecting the circle. The y-coordinate, so you write your x first and y. So y is 8. We don't know our x, right? So y is 8 means what? That this vertical length is 8. So I'm going to just write 8 here. This is 8. In order to find me all these ratios, I need to do what? I need to know this side. How do I do that? I have a right triangle. I already know 2 sides of the right triangle. I need to find the third one. So what do? I write my Pythagorean theorem. Always identify your C. Your C is your hypotenuse, which is 10. Your A is 8 square, and your B is you can call it x, or we can just leave it as b square. Solve for this. 8 square is 64 plus b square equals 100. Subtract 64. I get b square is equal to 36 and b is equal to 6. So this length is 6. Okay, but be very careful. We're in the second quadrant. We need to write our ASTC. Because guess what? Only my sine and cosecant are going to be positive. Rest, all these functions will be negative. So only cosine and cosecant are positive. Rest, everything is going to be negative because we're in the second quadrant. Okay? So that's where ASTC comes in handy. So I already know my 3 sides of the triangle. Use my SOHCAHTOA. I'm going to write that here. SOHCAHTOA. And come up with the ratios. So sine theta. Sine is opposite over hypotenuse. My theta is here, so opposite is 8 and hypotenuse is 10. And it's going to be positive, which I can simplify to 4/5. So my cosecant theta would be what? The reciprocal of it, which would be 5/4. Cosecant theta is adjacent over hypotenuse, so which is 6/10, but it's going to be what? Negative. Why it's negative? Because we're in the second quadrant and only sine is positive, sine and its reciprocal. So negative 6/10 and negative 3/5. This is very important, guys, doing the signs, because many students will get all the ratios right, but at times forget their signs and end up getting wrong answers. So be very careful of that, okay? And tangent theta is opposite over adjacent. So my opposite is 8. And it's going to be negative 2. And my adjacent is 6, which is 4/3. Negative 4/3. Right? So now all I need to do is secant theta and cotangent theta. The secant is what? Reciprocal of cosine. So it's going to be negative 5/3. And cotangent is going to be negative 3/4. So that's our all 6 trig functions, and that's how you find it. Be very careful. The picture, drawing the picture is the hard part. Once you draw the picture, you have to understand that your radius is always going to be the hypotenuse of your reference triangle. Hypotenuse, or it is the terminal ray. Okay, so that's how you do it. One more thing I wanted to highlight is many students get confused that if I wrote negative 6 over 10 is the negative. It doesn't matter whether the negative is with the numerator or denominator. Negative 6 over 10 can be rewritten as negative 6 over here and like this. And it's the same thing as writing 6 over negative 10. Okay, you can't put both the negatives. It is not same as negative 6 over negative 10 because the negatives cancel out and you're left with just 6 over 10. Okay, so doesn't matter where you put the negative as long as the sign is there. So finish up the remaining packet for homework, guys. Good luck.